Have you ever wondered how apps make smart choices? Like when a login system checks if your password is correct, and either lets you in, or blocks you out. Or how a game decides whether you've won, lost, or need to try again. Behind all of that, is something called conditional logic. And in C++, we do this using statements like if, else, and else if. These simple keywords allow your programs to make decisions, to react differently depending on the values it sees, and to control the flow of your code. In this video, we'll learn how to write conditions in C++, understand how they work behind the scenes, avoid common mistakes, and even build a small program together. Let's get started. So, what is a condition in programming? Simply put, a condition is a question your program asks. And depending on the answer, it decides what to do next. Think of it like this: is the temperature above 30 degrees? Did the user press enter? Is the score greater than 90? These are all examples of conditions. They're yes or no questions, also called Boolean expressions, because they always result in either true or false. If the condition is true, one block of code runs. If it's false, your program might either do nothing, or follow another path. This is how computers make decisions, and C++ gives us full control using the if, else, and else if statements. It's like giving your code a brain, the power to think before acting. Let's now look at the core building block of conditions in C++, the if statement. In its simplest form, an if statement checks whether a condition is true, and if it is, it runs the block of code inside the curly braces. Here's the basic structure: if, condition. Code to run if condition is true. Now let's make it real. Imagine we're checking someone's age to see if they're allowed to vote, int age equals 20, if age greater than or equal to 18. Cout you can vote. What's happening here? The program looks at the value of age. If it's greater than or equal to 18, the message, you can vote, is printed. Otherwise, the program skips that block entirely, nothing happens. So the if statement is your first tool to control the flow of a program, by making things happen only when a specific condition is met. And remember, the condition inside the parentheses must evaluate to either true or false. That's how the computer knows what to do. So far, we've learned that if allows us to run code only when a condition is true. But what if the condition is false? What should the program do then? That's where the else statement comes in. Else gives us a second path, a default block of code to execute when the if condition fails. Here's what it looks like: if, condition. Run this if true, else. Run this if false. Let's take our voting example and improve it. Int age equals 16, if age greater than or equal to 18. Cout you can vote, else. Cout sorry, you're too young to vote. Now the program always gives feedback. If age is 18 or more, it prints the voting message. Otherwise, it shows the too young message. This kind of logic is useful everywhere, from login attempts, to grading systems, to game mechanics, anytime you need to handle both possibilities. Think of else as the otherwise in your code. If this happens, do A, otherwise, do B. We've seen how if handles a single condition, and how else lets us respond when it's false. But what if we have more than two possibilities? That's where else if comes in. It allows us to chain multiple conditions, one after another, and the program will check them in order, from top to bottom. The moment it finds a condition that is true, it runs that block, and skips the rest. Here's an example. Let's say we want to assign a grade based on a student score, int score equals 85, if, score greater than or equal to 90. Cout grade, else if, score greater than or equal to 80. Cout grade, B, else if, score greater than or equal to 70. Cout grade, C, else. Cout keep practicing. In this case, the score is 85. The program checks the first condition, is it 90 or more? No. Then, is it 80 or more? Yes. So it prints grade B and ignores the rest. Else if gives your program more flexibility. It's like adding more if checks, but all connected in one logical structure. And don't forget, always order your conditions from most specific to most general, otherwise, earlier conditions might block the ones below. Now that you know how to use if, else, and else if, let's talk about something just as important: common mistakes. Even experienced programmers fall into these, especially when starting out. Mistake 1, using equals instead of equals equals. This is one of the most dangerous ones. If x equals 10. Cout x is 10. You might think this checks if x equals 10, but it doesn't. It actually assigns 10 to x, and the condition becomes true, because 10 is a non-zero value. To compare, you must use equals equals like this: if x equals 10. Mistake 2, forgetting the braces. If you write an if without braces, only the first line below it is considered part of the condition. That can lead to confusing bugs. Example: if score greater than or equal to 90. Cout great, cout you passed, looks fine. Actually, the second line always runs, even if the condition is false. Always use curly braces when writing conditional blocks, even if there's just one line. It's a good habit and helps avoid surprises. Mistake 3, wrong order in else-if chains. If you place general conditions before specific ones, the program might match the wrong block too early. For example, if score greater than or equal to 70. Cout C, else if score greater than or equal to 90. Cout A never runs. Always go from most specific to most general. From highest to lowest in numeric comparisons. Let's put everything we've learned into a real example, something practical that you can try on your own. We're going to build a small program that asks the user for their age and responds with a message based on that age. Here's the code: include iostream. Using namespace std, int main. Int age, cout enter your age, cint age, if age greater than or equal to 60. Cout enjoy your retirement, else if age greater than or equal to 18. Cout welcome, adult, else. Cout you're still young. Return 0. Let's break it down. First, we declare a variable called age, and we ask the user to enter their age using cin. Then comes the condition chain: if their age is 60 or more, we print, enjoy your retirement. If it's 18 or more but less than 60, we print, welcome, adult. And if it's less than 18, we print, you're still young. It's a simple way to personalize your program's output, based on real input and real conditions. Try running the code with different ages like 15, 25, and 70, and watch how the output changes depending on the logic. This is the power of conditionals in action, turning static code into interactive behavior. Alright. Time for a quick mini quiz to see how much you've understood. I'll show you a piece of C++ code, and I want you to think, what will it print? Ready? Let's go. Int score equals 75, if score greater than or equal to 90. Cout excellent, else if score greater than or equal to 80. Cout very good, else if score greater than or equal to 70. Cout good job, else. Cout keep working. So, what do you think this program will display when we run it? Let's walk through it. The value of score is 75. First condition, is it 90 or more? No. Second, is it 80 or more? No again. Third, is it 70 or more? Yes. So the correct output is, good job. If you got that right, awesome. If not, don't worry, just rewind and go over the conditions again. That's how you learn. Awesome work. If you've made it this far, give yourself a big round of applause. In this lesson, we tackled one of the most important concepts in programming, decision-making. You learned how to use if to check a condition, else to handle what happens when it's false, else if to create multiple logic paths, and how to avoid common beginner mistakes that can lead to unexpected behavior. You also saw how all of that comes together in a real, interactive program. These conditional tools are essential in every C++ program. They give your code the power to think, to choose, and to react. But what if your program needs to do something over and over again? Like counting from 1 to 10, checking thousands of items, or waiting for user input in a loop. That's where we're headed next. In the upcoming video, we'll dive into loops in C++, starting with for, then while, and finally do-while loops. You'll learn how to write clean, efficient, and powerful code that repeats actions automatically, until you decide to stop. If you've ever wondered how programs build progress bars, track time, or keep games running, loops are the answer. So make sure you're subscribed, and don't miss the next episode. Until then, keep practicing, keep building, and as always, happy coding.